let's start Chapter 5. Chapter 5 is all about polynomials and polynomial functions and dealing with polynomials and adding and subtracting and multiplying and dividing and simplifying and all that good stuff. Okay? So it's all good stuff. When it's all said and done, you're just adding, subtracting, multiplying, and dividing in this chapter. We're going to talk a little bit later this week about end behavior, but you've already talked about that. You did a lot of that in Algebra 2, so that should, again, be a refresher. We should be refreshing up and through this week, and then after this week, then we start newer type stuff and more in-depth into some topics that you might have already seen already. Today, we're going to talk about exponents. Okay? Now, you've dealt with exponents for years. Okay? I don't know if you dealt with them in 8th grade or not. I have a thinking that you might have started them in 8th grade. I know for sure you did them as in whatever class you took as a 9th grader. I know you did it whatever class you took as a 10th grader and whatever class you took as an 11th grader. So the Algebra 1, you did them. Geometry, you did them. Algebra 2, you did them. Okay, so that's kind of those three classes, I know you did them. I don't know, I think you did some of them in 8th grade. So this, again, should be a refresher. Now, with that being said, they are the hardest ones to remember, okay? Because you just do them, and most of the time you do them right, but most of the time you're like, I don't remember what I'm supposed to do there, okay? So in order to facilitate that, I'm going to remind you that x to the 4th is x times x times x times x. Okay? So I'm going to give you that prompting, and then I'm going to say, why don't you, as a test, kind of a pre-test, if you will, why don't you try those 6 problems on your own? Okay? So try those 6 problems on your own right now. I am not going to go through how to do all of these. I'm just going to give you the answers to all of these because then that's what we're talking about today. So on this first one, you should have gotten x to the 7th power. On the second one here, you should have gotten 8x to the 6th power. On the third one here, you should have gotten x to the 5th power. On the fourth one here, you should have gotten x to the 8th power divided by 9y squared. On the fifth one, you should have gotten x to the 12th. And on the 6th one, you should have gotten 1 over x to the 5th power is what you should have gotten on those 6. Okay? If you got some of those, good. If you've got all of those, great. If you got none of those, we've got some work to do. Okay? All right? And that's what we're going to do today. So, the rules that you need to know. Now, I am not going to require you to memorize what the property's name is. First one is product property. Second one is power to a power, or power of a power property. Third one is quotient. Next one is negative exponent property, etc. I'm not worried about all that. I'm more concerned about you knowing how to use the properties and what to do with them. Okay? So, on this first one, when I have the same base, and I am multiplying, I add the exponents. The base stays the base, so this is a times m plus n. The base stays, I add the exponents. Okay? On the second one, when I have a power to a power, I multiply. the exponents. So this would be, whoa, tap the brakes. Come on back to me. So this would be a to the m times n power. When I have the same base, and I am dividing, I subtract the exponents. So this is a to the m minus n power. Okay. But I'll show you a little bit later on a different way of thinking about a quotient one, like number 3. In number 4, the negative exponent property, we don't like negative exponents. So this becomes 1 over a to the m power. Okay? So if the negative exponent is on top in the numerator of the fraction, we move it to the denominator and it becomes positive. If it's in the denominator, we move it to the top, to the numerator, to become positive. Or, little side note, if it's a fraction to a negative exponent, another thing that I could do is I could reciprocate the fraction and then take it to a positive exponent. Okay? I can reciprocate the fraction to make it become a positive exponent then. Okay? Or I could, take the power to the top and take the power to the bottom and go through like that. In number 5, anything to the 0 power is 1. Okay. A to the 0 power is 1. 52 to the 0 power is 1. The phone on the wall to the 0 power is 1. Okay? Anything to the 0 power is 1. Okay. Number 6 really isn't so much a property as just a remembrance. And the remembrance here is that the exponent only controls what is directly in front of it. So in this particular one, the parentheses is directly in front of the exponent. A is in front of that parentheses, so that is not being controlled by the exponent. but B and C both are being controlled by the exponent. Okay. So just because you see an exponent in the problem doesn't mean that everything is being controlled by it. Only what's inside the parentheses, if there's one on a parentheses, or what's directly in front of that exponent. Okay? So with those being said, let's try some more like those warm-up problems that we had. Okay? So I write down a lot more than how I normally do these problems. Okay? I write down a lot more than how I normally do it. So this is really like 2 to the first power times my exponent of 3. So my exponent of 3 is controlling everything inside that set of parentheses. And then that's going to be times x cubed. That exponent has to be multiplied by 3. And then the y also has to be multiplied by 3. One times 3 is 3. 2 to the third power, because it's a number, we can take that to its power and we can actually do those. Variables we can't, numbers we can. So 2 to the third power is 2 times 2 is 4 times 2 more is 8. So this is 8 x to the 9th y to the 6th. Dividing fractions here in number 2, I subtract the exponents. So this is x to the -3 minus -7 power. -3 minus -7 is like -3 plus 7, which is 4. So this is x to the 4th power. Now, there's a couple of different ways to do that one. We could have also said, well, I don't like negative exponents because nobody in math does. So let's get rid of the negative exponent. So then that would have become x to the 7th over x cubed. Now the exponents are both positive. And again, you could do it 7 minus 3. Okay, which would still get you a positive 4. Or you could have also, and this is what I alluded to earlier, you could have also done it this way. You could have said, well, there's 7 x's on top, and there's 3 x's on the bottom. So the top has 4 more x's than the bottom. Okay? So where are more x's? On top. How many more? 4 more. Well, that means x to the 4th. If it would have been reversed, reciprocated, and it would have been x cubed over x to the 7th, there would have been 4 more x's on the bottom, so it would have been 1 over x to the 4th. Okay? Questions on that? Either one of those two. Okay? What I'd like you to do now is I would like you to try those 4.
Hopefully you paused and are doing these.
So a spot check here on number 3. So this would be 2 times -3 because the numbers don't have any exponents on them. So we can just multiply those two numbers together. Then times x cubed plus x, plus the exponent is 3 plus 2. And then times my y's now. negative 4 plus negative 2. That's a bad looking negatives in there. So that's going to be 2 times negative 3 is negative 6. 3 plus 2 is 5. Negative 4 plus negative 2 is negative 6. So that, to me, my final answer would be negative 6x to the 5th all over y to the 6th power. Questions on that one? Okay, give you time to finish off the other 3. So in number 4 here, that's going to be 4 to the 1st power times negative 3. And then that's going to be m to the negative 2 power times negative 3. Oops, that didn't work out well for me. It just became a big long negative sign. And then it's going to be n to the 4th power times negative 3. Okay. So that gives me 4 to the negative 3 power, m to the positive 6 power, n to the negative 12 power. Okay. 4 to the negative 3 power. That means that one's going to the bottom and becoming 4 cubed down there. Well, 4 cubed is 4 times 4, which is 16, times 4 more is 64. So that becomes 64 down on the bottom. M to the 6th, that's positive. That stays up on top. N to the negative 12th becomes positive by moving it to the bottom. And I get that as my final answer. Questions on that one? On this first one, 8 over 12, I can divide those two numbers. And then C's, I'm going to subtract them, so that's going to be negative 2 minus 1. And then D's, 3 minus 4. So 8/12, 8 can be divided by 4, 12 can be divided by 4, so that becomes 2/3 times C to the negative 3rd power times D to the negative 1 power. So to make that become a nice looking fraction, that would be 2 on top, 3 on the bottom, C cubed on the bottom, and just D on the bottom, D to the 1st power on the bottom. Good to go on that one? This one becomes negative 3 to the 1st power times 3, x to the 4th power times 3, y to the 3rd power times 3. That one's on the bottom. So that becomes negative 3 to the 3rd power, which is negative 27, x to the 12th power, y to the 9th power. Okay. Good with that one? Okay. Scientific notation. You've probably seen it at some point in time in a science class. Scientific notation is a way to represent or a way to write. I like a way to write, not represent. A way to write, I like better. A way to write really large or small numbers. Okay. So we can write really big numbers, like we can write 1,000,000. 1,000,000 is 1 times 10 to the 6th power. Okay. Or we can write really small numbers with it. Okay. So because the really large numbers have positive exponents, oops, I should put it underneath here. And the really small numbers have negative exponents. We can have negative exponents in scientific notation. And we can have that. It's the only time that we will allow negative exponents. Scientific notation comes with it one rule, and the one rule is that only one digit can be left of the decimal point. Okay? Which is why they're all written like here and here and here and here. Okay? Only one number to the left of the decimal point. Okay? We will only be multiplying and dividing numbers in scientific notation. It is very hard to add and subtract numbers in scientific notation because they're just different sizes. Okay? So multiplying and dividing will be what we do. And how we do is we take the number, the term that's in front of the times 10 to the whatever power, we take those numbers and we do whatever it is we are doing. In this case, in number 7's case, we're multiplying. So I would multiply those two numbers. Then, with the times 10 to the whatever, we add those exponents. Or if we are dividing, we subtract those exponents. Top minus bottom. So I'm going to need a little assistance here. 6.8 times 3.6. Anybody? $6.8 times 3.6.
24.48.
24.48 times 10 to the 10th power. Do we agree with that? Okay. So we've done that math. However, what's wrong with that one? It's over one too many, right? I have 2 digits in front of my decimal point. Okay? So I need to move this decimal point one more to the left, which is going to add 1 to my exponent. So my final answer here is 2.448 times 10 to the 11th power. It's kind of reverse thinking. Okay? If I had 7,800, so 7,800, in scientific notation, that is 7.8 times 10 to the third, because I take this decimal point and I move it 3 spots to the left. If I had 0.00078, that would be, I would take this decimal point 1, 2, 3, 4 to the right, so this would become 7.8 times 10 to the negative 4th. If I move that decimal point to the left, I add 1 to my exponent. If I move that decimal point to the right, I subtract 1 from my exponent. Okay? So then here on number 8, I'm going to take 9.3 and I'm going to divide it by 3.1. And with my exponents, I'm going to subtract them. Top minus bottom. 9.3 divided by 3.1 is 3. So my final answer here is 3 times 10 to the 12th. Which is 3 with 12 zeros behind it. Or 3 trillion. Okay? And you've done some of that, I'm sure, in a science class at some point in time to get up to this point in time and ready for graduation. Okay? So, write an expression for the figure's volume in terms of x. Well, the volume of this figure is pi times r squared times h. Okay? So, this number here would be my r, and this number here would be my h. So all I'm doing here is I'm substituting those values into my formula and then simplifying it. Okay? So this is going to be pi times r squared. R was 2x. That needs to be squared. Times my h, which is that. Okay. So 2x quantity squared would be 2 squared. What's 2 squared? 2 squared. This would be one that everybody in the room should be saying. 2 squared. 2 squared. Everybody, 2 squared. Everybody, 2 squared.
4.
When you know it, shout it out. It's 4. Okay? What is x squared? It's x squared. X squared. It's a trick question. I was giving it to you. Okay? So we applied our exponent there. We still have to multiply it by pi, and we still have to multiply it by x over 3. So in my brain, I'm thinking about all of these as over 1. And when I multiply fractions, remember I multiply all the tops together. So that would give me a volume here of 4 pi times x cubed. And then I would multiply all my denominators together. 1 times 1 times 3 is 3. And that is an expression, actually it's an equation, an expression for the figure's volume in terms of x. 4 pi x cubed divided by 3. Okay? Here is your homework. Again, I remind you that the answers are posted online on It's Learning for your checking, not for your doing. Okay? I was nice this past weekend when I was grading your homework, and I gave you points for doing the homework. I have 4 different cheats, or way to pick out who's copying the homework. Okay? This last week's one was there were extra problems online than there were assigned in class. Okay? From now on, you get 0 points for copying homework. Okay? And there's, in every single one of my homeworks, there's a way that I know of who's copying and who's not. Okay? Sometimes I catch you, sometimes I don't. When you do that, when you copy the homework, who are you cheating? Yourself. You're not cheating me at all. Okay? You're not cheating me. You're cheating yourself. Okay? Because this stuff's going to come back on quizzes and tests. Okay? So I just want you to do the problems.